Alright nerds, let's talk about enthalpy and bond energies. So we want to be able to calculate the enthalpy of reaction using bond energies or bond enthalpies. But we also want to be able to explain the exothermic and endothermic nature of breaking and reforming new bonds. So our vocab for this lesson, I just need you to pause the video here and write this down so you've got something to refer back to as we go through. And again, the focus here is bond enthalpy, which I will use bond energy and bond enthalpy interchangeably. So here we have our reaction diagram, and you can actually see this is just our reaction coordinates along this end, and there's the energy. So we have our reactants energy, then it goes up to what would be our activation energy, and then back down to our energy stored in our products. So what we're looking at with enthalpy is we're really looking at inside the arrow. What's happening inside that little part there? This is where the chemistry actually occurs. And the first thing we need to know is that for a reaction to occur, all the bonds are broken, and everything's broken into individual atoms to start off with. So all bond enthalpies are overcome. In other words, we put enough energy in to overcome those bond enthalpies, and this step is always endothermic. And this is also known as the activation energy. All these bond enthalpies combined in the reactants becomes our activation energy. So the energy is released as new bonds are formed, and this step is always exothermic. So we put energy in to make the reaction happen, and as the reaction progresses, energy is released. So the difference in bond enthalpies, so the bond energy on the reactants and the products, is where we come down to the delta H of the reaction. So this is all the energy stored in the bonds. This is the energy stored in the bonds here. This is the energy required to overcome that. Okay, so that's the bond enthalpies. And here we have our reaction enthalpy at the end. So let's have a look at bond energy and enthalpy and how it all works. First, at times, delta H or Q may be hard to measure directly. So we might have multiple reactions happening at the same time. It might be in a way that's almost impossible to measure. Usually it's when there's multiple components reacting at the same time, it gets really hard to measure to tease out which ones the bond energies for which. So delta H of reaction can be calculated using our bond energies or enthalpies. And here's the table we have here. So with our reaction of 2 hydrogens plus an oxygen going to 2 waters, this is an exothermic reaction. Okay, so we've got to subtract the energy required to break the bonds from the energy required for the forming. So basically, this is the bond energies of the products, okay, and the bond energies of the reactants. And what we have here is we have, so this is the bond breaking, okay? So this is actually our reactants, and we're putting all those together. And as we add them up, they come from this table over here. Sorry, that was me pausing as I was thinking. Then we add these up, they come from this table over here. So we have 2 hydrogen bonds, and that's our 2 times 436, plus our 498, which is our 1 oxygen to oxygen bond, which is down here. And we subtract from that the bond of the energy stored in reforming. So here we go from 2 times 463. Okay, sorry. So it's basically oxygen to hydrogen bonds, and there's 2 of them. Actually, there's 4 of them because it's 2 there, and we times that by 2. All right, so 4 times 463, or 463 plus 463 times 2, and we subtract that from there, right? And this gives us a negative 482. So this is the reverse of the way we think of enthalpy, and I'll show you why back on that previous page. The reason this is the reverse of what we think of enthalpy is we're subtracting, so we're adding up our bond breaking, our bond breaking, which is this one here, and we're taking away from that this energy here, the bond forming. And that leftover part there is our reaction. So that's why it's backwards. Normally, if we're using the enthalpies of formation, we'll use the enthalpies of formation of this side minus the enthalpies of formation of this. But when we use bond energies, we're actually looking at the energy breaking the bonds, taking away from that the energy of forming the bonds. And yeah, I hope that made sense. It's pretty complex. It's a pretty obtuse idea because it goes backwards to the way we would normally calculate enthalpy. So again, I hope that made sense. If it didn't, if you have any questions, put them in the comments below and we'll get back to you as quick as we can. Thanks for watching. See you next time. Bye now.